Hello everybody, this is Carmichael the Cat, and welcome to your 9th C++ tutorial. In this tutorial, we will be going over references, so let's get started. We're using some of the code from last tutorial, but I deleted a lot of it because it's no longer necessary. So let's get into what a reference is. So basically, a reference is just a nickname for a variable. And that probably doesn't make much sense to you yet, but once we start using it, you'll probably start getting it. So let's create a variable. We'll say int x equals 10. And then we do int ampersand y equals x. So what this is doing is it's creating a reference. It's not a variable, it's a reference called y, and it's just sending it to x. So it's a nickname for x that's called y. So everything that we do to y will also be done to x, and everything we do to x will be done to y, and so on. So let's say y plus equals 5. So we're just adding 5 to y. So now let's output y and x. So standard count y, standard end line, and standard count x, standard end line. So now let's build this. And 15 and 15. So you can see that they've both been turned into 15, even though we added 5 to y. We never added 5 to x. But since y is just a reference or a nickname for x, then x is also having 5 added to it, just like y. So this still probably doesn't seem very useful to you, and that's because you'll never really use a reference like this. References are almost always used for functions. So to show you how references can be used for functions, let's first delete this. We don't need it anymore. And now let's make some changes to our add function. So what we're going to do is we're going to add the reference sign to the parameters here and here. You have to do it both places. It'll create an error otherwise. And now let's actually create some changes to the function itself. Let's say num1 plus equal, not equals equals, plus equals num2. And I want to show you what happens if we do this before we change these to references. So let's just make these normal variables. So num1 plus equals num2. And now return num1. So this function will still do the same thing as it would have done before, but we're just writing it differently. So let's say x equals 10 and y equals 20 semicolons. Alright, so x equals 10, int. I was recently coding in Lua, so I forget to do these sometimes. Alright, so int x equals 10 and int y equals 20. So let's do add x and y. And then we will output x. Oh, did I? Oh, I capitalized add. I know, I'm surprised I didn't catch that in the last tutorial. You shouldn't capitalize function names. Someday I'll go into proper variable naming patterns soon because it's important. So we're doing add x and y, and then we're outputting x. So let's build this. And x is 10. So we passed in x to the function, and x got 20 added to it because, actually, let's just make this a constant. X and 5, so it's easier to understand. So x is 10, even though it got 5 added to it here. Now, the reason that x didn't get changed when it was passed into the function is because if you don't pass in variables as a reference to a function, then what the function does is it creates a copy of that variable and then uses it as the parameter. So a lot of the time we do want that, but say we don't want that, then that's where we use references. So let's just put the and here. So now if we build this, oh, I see. We don't want a reference here. So int and num1. So now num1 is a reference. So let's see what happens now. X is 15 because if you pass the variable in as a reference, it will use the original variable that was passed in as the variable parameter in the function instead of creating a copy of it. So X is actually changed to 15 instead of just staying as 10. So that's the main way you'll use references, and it's very useful. You'll end up using it a lot. But another very good way to use references is to speed up your program. So, like I said, if you pass in a variable by reference, then it will not create a copy of that variable. It will use the original variable. But if you pass it in without a reference, then the function will have to create a copy of that variable. And now with an int or a bool or small data types like that, it'll be almost instant. You won't notice any kind of speed difference. But with big types like strings, we'll get into vectors later, they're pretty big. And if you go into any kind of graphic programming, then copying an image takes a lot of processing power. So the way to get around that, we're going to create a function prototype. We're not actually going to define the function because it's unneeded. So we'll create a function with a string return type. String, we'll call this, we'll just make it an overload of add. So string, we'll call it v1 and string v2. So this is the improper way to do it, because every time you pass in a string to this function, it will have to create a copy of that string. And usually strings aren't too big, but it could still make a noticeable difference. So what you want to do instead is you want to pass it in as a reference to a string. So then it won't have to create a copy of that string.